In this lesson, I'll show you 6 examples on how to integrate indefinite integrals of simple functions. This video caters to students who are new to integration or need a quick refresher after many years of being away from the classroom. Think of this video as a starter kit to integration. Throughout this video, you'll hear me use the words integrate and antiderivative interchangeably, because that's what an integral is. It's the antiderivative of a function. So by integrating a function, we're going from its derivative, denoted as little f at x, back to its original function, capital F at x. Let's start with question 1. In question 1, we're expected to find the integral of 5 dx. One thing to keep in mind is that if you have a constant being integrated, in our case this 5, you can pull that constant outside of the integral. For instance, this 5, according to this rule right here, can be pulled outside so that the function becomes 5 times the integral, and this symbol denotes that, dx. Now we can go on to use rule 1, which tells us that if we are finding the integral of dx, the answer is x plus c, where c represents an arbitrary constant. So the solution to this problem is big F at x is equal to 5 bracket x plus c, or simply 5x plus c. In question 2, we're asked to integrate 3x squared plus 5 dx. To integrate this successfully, we'll need to use all 4 rules. To touch up on rule 3, if we have separate terms, in our case this function has 2 terms, each of these terms can be integrated individually. For instance, instead of 3x squared plus 5, we can write down the integral of 3x squared dx plus the integral of 5 dx. To find the integral of 3x squared, well, first we can take out this constant 3 outside, and now all we have to do is find the integral of x to the power of 2 dx. To do that, we'll use rule 4, which says that to find the integral of x to the power of 2, we will increase the exponent by 1, and then whatever that sum is, 2 plus 1 is 3, you divide the whole function by 3. So we have 3 x to the power of 3 over 3. This 3 and this 3 cancel out, and that's the integral of this first term. We're not going to add plus c yet because we'll just add it to this one. The integral of 5 dx, and we found the answer to this in question 1, was simply 5x. So we have x to the power of 3 plus 5x plus c. Our final solution is big F at x is equal to x to the power of 3 plus 5x plus c. Let's move on to question 3. In question 3, they want us to integrate 7x to the power of 3 dx. Once again, I'll use rule 4 predominantly to find the solution. X to the power of 3 becomes x to the power of 4 over 4. You leave the 7 where it is, plus c. In question 4, they ask us to integrate the cube root of x. I'm going to change this format from radical form to exponents with fractions. So instead of this third root of x, I'll write down the integral of x to the power of a third. I'll use rule 4, which tells me that I can add 1, and then whatever that is equal to, you divide the whole function by it. A third plus 1 is equal to 4 over 3. So our answer becomes big F at x is equal to 3x to the power of 4 over 3 over 4. You're probably wondering how 4 over 3 became 3 over 4. It's a simple quotient divided by a quotient problem. We have x to the power of 4 over 3 divided by 4 over 3. You flip this fraction and you switch this to multiply, where you end up with 3 times x to the power of 4 over 3 over 4. In question 5, they want us to integrate 1 over x to the power of 3. Once again, we'll use rule 4, and instead of having t to the power of 3 at the bottom, I can write down this function as the integral of t to the power of negative 3 dt. Rule 4 tells me that I can add 1 to this 3, which becomes negative 2, and divide the whole function by negative 2. That is my antiderivative. Big F at t is equal to t to the power of negative 2 over negative 2, or, if your teacher doesn't like negative exponents, 1 over negative 2 times t to the power of 2. Lastly, in question 6, this is the most challenging one out of these 6 examples. We have to distribute this x to each of the terms in the numerator. Watch what happens if you do that. The integral of x to the power of 5 over x dx minus the integral of 2x to the power of 3 over x, don't forget the dx, plus the integral of 5x over x dx. This x will cancel out with one of these. This x will cancel out with one of these, and this will cancel out with the 5x. We know the integral of 5. We've done 2 examples. This becomes 5x plus c. The integral of 2x squared, this 2 becomes 2 plus 1, which is 3. Divide everything by 3, you get 2 over 3x to the power of 3. And lastly, the integral of x to the power of 4 is x to the power of 5 over 5. Therefore, this function right here, represented as capital F at x, is the solution for question 6. And there you have it, 6 examples on how to integrate indefinite integrals of simple functions.